Here we go. Starting our next session. And Shelby, let me bring you to the stage. Boom, boom, boom. I know you also have an awesome... Hey, there you are. How's it going?
Good. Happy to be here.
Yes, I'm very excited for your talk. I know that the last time that we had a little virtual encounter was at one of the MLOps community events.
Yeah.
It was awesome. And so I'm going to get out of the way because, as you probably heard me say earlier, the floor is yours and I have one job, which is to keep us on time. I'm going to throw your screen share up and I will see you in 10 minutes.
Thank you so much. Yeah, super excited to be here. So we're all here today for, a similar reason. We know that data is the key for all of our enterprises, but more importantly, data is the key for AI, right? There's not going to be any good AI without strong data. And so I'm really excited to talk to you about an emerging type of data that you're going to be seeing more and more today. It's called trajectory data. So not sure if you've heard of this, but this trajectory data is something my team at Salesforce spends a ton of time on. We spend so much time synthetically generating this specific type of data so that we can build really strong, really capable, really fast agents. So yeah, let's just dive in. So before I dive in, just a little bit of background about myself. As I just mentioned, I lead an AI research team at Salesforce. We build AI, the next generation of AI for our products, ultimately for our customers, right? And some of the key areas my team focuses on are AI agents, which is going to be the focus of today, but also similar topics, small language models that we'll need for agents, on-device AI, maybe there's a future for on-device agents. And we publish a lot of our research. We open source a lot of our models and data sets. So everything I'm going to talk about today, it's going to be completely free and open source for you to get started with, to try, to experience. So I'll give you links at the end for you to be able to see what trajectory data really looks like and how you can even use it to train and up-level your own agents. And always happy to connect. Feel free to scan the QR code to chat offline about these things. So yeah, what is trajectory data? Let's go to something that we all know. We all know about LLMs at this point, right? We all know we can give an LLM a great prompt like this, draft an email, we send it to the LLM, it's going to generate a great email. We know LLMs at this point. But let's think about what we need for agents. Agents are more than just generating text. Agents are able to take action. So if you look at this prompt here, which is saying, what meetings are on my calendar this afternoon, a plain LLM, just an LLM, is not going to be able to generate the right answer for this alone, right? An LLM is trained on historical old data, essentially. There's no way an LLM will know what's going to be on your calendar this afternoon unless we empower that LLM to be able to take action. Maybe that LLM is able to call your calendar app and extract information from the calendar app, or call any other apps. So the ability to take action is absolutely key for an AI agent, right? So we need our agents to be able to take action using external tools, apps, databases, and so on, so that you can actually answer prompts like this. So what do we mean by an action? So it's still going to be the LLM generating this action. If we go back to that slide, the LLM is still generating an action. So, but what does an action look like? Well, it's still text. It's still text. It's text that specifies, one, the correct tool or app to use. Okay, and then two, that's not enough, right? Just knowing what app is relevant here is not enough to actually take action. We also need to know what functions or or how to use that tool or app. So going in our running example, if we look at this prompt, again, what meetings are on my calendar this afternoon? The correct action to make it executable would be to specify the calendar app and also specify which functions to use in that calendar app. As you can imagine, lots of things to do in a calendar app. We could add events, remove events. The key here is that given that prompt, the right function would be selected. So another key here is that action is completely executable. So how do we get our models to be able to take action, to generate actions well? Well, a lot of LLMs, a lot of great foundation models are already pretty good at this, but for specific use cases, for more complex use cases, we need further training of our models. And the key here is that models learn to act by seeing actions. So this is what training data is all about, right? And this is exactly what trajectory data is. Trajectory data is step-by-step action demonstrations. So let's take a look at this quick example here. Imagine we have a task. Maybe we have an agent that's able to help us with, maybe this agent's able to help us on our phone, for example. And a sample task would be, what is the phone number and email of my friend Astro? Maybe that's something we would need the agent to help us with. The correct actions to take, or that action trajectory, would be to navigate contacts and get the phone number of Astro. So that would be, so as you can see here, this is a very simple API type call. The second step would be to navigate contacts and get the email of Astro. So this right here, what you see here, this task and action trajectory is one data point, only one data point. So imagine if we can generate hundreds or thousands of data points, we can train our agents to be amazing at taking actions in the right situations. So here's some things to think about when we're developing trajectory training data. We want to have simple trajectories all the way to complex trajectories, right? That's going to really empower the abilities of our agents. So one thing we talk about is single-step trajectories. Single-step trajectories are just tasks that require only a single step to complete. You'll definitely want some of those in the training data. Now, we also, as we all get comfortable with AI agents, we're using them more often, we're expecting more of them. We want our agents to be able to help us with more and more complex tasks. In that case, we'll want to have multiple steps or multiple turn trajectory data. So what I mean by that are tasks that are going to require multiple tool calls, multiple conversation calls, right? Agents are not just are often going to need to talk to the user to get more information. So we'll want trajectory data that includes that. And finally, we're going to want domain-specific trajectory data. So imagine agents that are functioning in marketing tools, or agents that's functioning on the web, or agents that are functioning among different databases. Depending on where your agent is functioning, you're going to want to have trajectory data that represents that domain, that represents that use case. So this all sounds great, but how do we get this type of trajectory data? So I want to give you a couple ideas to help you get started today. The first is, and the main thing my team works on is synthetically generating this trajectory data. Remember, when we talk about that trajectory data, it is task and correct actions to take to execute that task. So the correct APIs to call. We synthetically generate that. And so what I have here today, what I've listed here are two papers that we recently released called API Gen and API Gen Multi-Turn, MT. Check out these two papers. We've outlined our entire pipeline on how we've synthetically generated these types of trajectories. So we'll use LLMs to help us generate, but then we'll have systems for actually checking, is that trajectory correct? Is the quality good? Is it diverse enough? Is it domain specific? We've made progress in all those areas. Links will be at the end of this presentation too. Now, so besides synthetically generating trajectory data, I want to share that there's a lot of trajectory data already open source as well. So we released a couple of open source data sets on Hugging Face, and you can take a look at that at the end. And of course, human annotation. This is always a great option, right? If you can have a team of human annotators who can help you create those trajectories, who maybe can actually use the systems. Maybe you have a team that is actually using your system. You could actually executing tasks right within your system. You can track the API calls they're making, the clicks, whatever it takes to get that task done. That's also a very valid way to get trajectory data. Now, I want to share, wrapping this up, I talked to you about what this data does in the power of it. I want to show you, if you generate the synthetic data, how your models can become stronger. So we've done just that at Salesforce. We've synthetically generated lots of trajectories. We've trained a model, and we call it XLAM. So this is completely open source, everyone. It's completely available on Hugging Face. I'll share a link at the end. These are what we call our large action models. So what we did is we've taken several pre-trained base models, open source. We've synthetically generated thousands of trajectories, as I mentioned. We fine-tuned those models. And as a result, we have a set of 5 models ranging from 1B, 1 billion parameters, all the way up to 7 billion parameters. That is, most importantly, ranking number 1 on function calling leaderboards. So our models, even being a fraction of the size, are beating GPT-4o, Claude, and other industry leaders. And the key was that we synthetically generated these trajectories, so our models are just amazing at taking action. So again, all open source. And if you look at the Berkeley function calling leaderboard, this is one of the main leaderboards for tool calling, for agentic, for agents. You can see that our models, sometimes being a fraction of the size, rank towards the top of that leaderboard. I'll specifically call out number 4 here, our 8B model, 8 billion parameters. You can see is ranking above even GPT-4o. And again, it all, most of that was because of our training data. Data is the key to getting any of these AI models to perform. So quickly, you can see here our 3B model, really small model, ranking 13. And even the 1B model, if you look at, that's only 1 billion parameters. It's still beating a lot of the industry leaders. Awesome. So hopefully that gave you a preview of what trajectory data is. Keep an eye out for it. You'll see more and more about trajectory data. If you're interested in checking out our completely open source models and that data that we open source, that trajectory data, you can scan the QR code here. Also, we started a YouTube series about this. So check out our YouTube series. Thank you all so much.
I like everything that you just said, and we need to chat more because there's so many questions that I have in my head. There's a lot of questions that are coming through in the chat. I'm going to direct you, Shelby, to those questions. I also think that you're in San Francisco, right?
Yeah.
We're doing a whole agents event next week. I'm going to try and sync with you offline about that because I want to hear more about this. For now, though, as you know, I have one job and one only, and I'm going to do it well. I promise. Now, we're going to keep it moving. Thank you, Shelby. And
thank you. Take care.
We will see you soon. Let's jump to the next session.